student, today this is the lecture number 11 of unit 2, that is introduction to instrument characteristics. In the previous lecture we have studied what is resolution, what is sensitivity, what is threshold and what is deflection factor. That four static characteristics we have studied in the previous lecture. Today we are going to study the precision and accuracy. What is precision and accuracy? For that purpose we will have to take the example of one of the sport activity, that is archery. Okay, in case of the archery, you know that there is a one target. Okay, so there is one target board, and on target board from a near about 100 meter or 50-meter distance away, the archer has to bow the arrow on the target. Okay, so in the central part, suppose the maximum number of arrows will be targeted. In that case the athlete will get the maximum points. Okay, so every archer has tried to target in the center of the target board. Okay, so in that case, suppose any archer targeted the maximum number of arrow in the center, he will get the maximum point. Okay, now in this case suppose first arrow is targeted here, second arrow is targeted somewhat here, third arrow here, fourth here and fifth here. Okay, likewise the five arrows are targeted in the center, that is in the target area. Okay, so in that case we may call it as a high accuracy. We may call it as a high accuracy. Accuracy will be high. Okay, means what? The maximum number of arrows by the archer targeted in the bull's eye. That central part or central circle is known as a bull's eye. Okay, so what we can say that the archer has a targeted maximum number of arrow in the bull's eye. That's why the accuracy of that archer is 100%. Okay, and accuracy of that archer is higher. Now in case of the precision, the most of the, or what we can say that all the arrows are targeted at the or nearly close to the same point. Okay, because there is no lot much distance between the targeted point of the each arrow. That's why the precision is also high. That's why the precision is also high. Okay, that's why precision is also high. Means in that case we can say that the accuracy as well as precision is high when the archer will targeted all the arrow in the bull's eye. Okay, accuracy means what? Maximum number of arrows are targeted in the bull's eye, and precision means what? The maximum number of arrows are marked at a point nearer or closer to each other. Okay, so that's why we can say that the accuracy and precision of that archer is higher. Okay, now we have taken the another example. Okay, in that case there is a another sorry, this one will be the another uh, target. Okay, and this is nothing but the bullseye. Now here that archer has targeted somewhere here, somewhere here, somewhere here, somewhere here, somewhere here. So in that case what we will say, in that case that archer has missed the bullseye. So means by an larger amount or larger distance. That's why we can say that the accuracy of that archer is lower. Accuracy of that archer is lower. Okay, means what? That archer has missed the bull's eye by a lot more or much more distance. But in case of the precision, what we can say, whatever the first arrow he has targeted, the second arrow is having the nearer distance, third arrow is having again the nearer distance, fourth arrow is having again the somewhat in the vicinity, and fifth arrow is also is in the vicinity. Okay, so whatever the distance between each and every arrow, that is not much more. Okay, means there is a closeness between the each and every arrow. Okay, so that's why we can say that the precision is higher. Means what? Whatever the distance between the one and all arrow is not much more, but he has missed the bullseye. That's why the accuracy is lower, and about the precision is higher. Okay, so from this we can understood that in order to obtain the higher accuracy, we will have to target the both or all the arrows in the bullseye. Means what? It will showing the accuracy of the archer. Okay, and if he is able to targeted all the arrow in the bullseye, in that case the accuracy as well as precision is higher, because the internal distance, or what we can say that the distance between the each and every arrow in case of the first diagram is in case of the first diagram is higher. Okay, and in case of the second image or second diagram, we can say that that archer has missed the bullseye, but whatever the arrows he has marked on the target board, that having very less distance between each other, that's why we can say that the precision is higher. Okay, understood all of you? Okay, so now we will go through the definition given over here. The precision, the, these terms refer to the closeness or agreement among several measurement of the same values with the same instrument by the sum operator over a short time span. Okay, the accuracy refers to the closeness to the true value of the quantity under measurement. Now we are understanding that accuracy and precision with the help of measuring instrument. Okay, so in case of the measuring instrument, the accuracy refer to the closeness to the true value of the quantity under measurement. म्हणजेच जी क्वांटिटी अंडर मेजरमेंट आहे त्याची क्लोजनेस कुठं असायला पाहिजे, क्लोजनेस टू दी ट्रू व्हॅल्यू ऑफ द मेजरिंग इन्स्ट्रुमेंट. ट्रू व्हॅल्यू, ओके, जी ॲक्च्युअल व्हॅल्यू आहे किंवा ट्रू व्हॅल्यू आहे त्याच्या नियरर मेजर्ड व्हॅल्यू असायला पाहिजे. दॅट इज नथिंग बट द ॲक्युरेसी, अँड दॅट वी हॅव अंडरस्टूड विथ द हेल्प ऑफ दॅट example of archery game. Okay, then precision refer to the degree of agreement within a group of measurement. Okay, the degree of agreement means what? The instrument is giving the same reading, is not closest to the true value, but it is giving repeatedly. Okay, so that is it's prescribe the ability of the instrument to reproduce its reading over and over again for a constant input signal. Okay, means repeatedly it is giving the same reading. Okay, and repeatability means what? Pertain to the closeness of the output reading when the same input is applied repeatedly over a short period of time. Means over a short period of time, the 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 instrument is showing continuously the same reading for the same input. Okay, okay, but there is a certain measuring lag. Okay, the condition, same instrument, observer, same location, and same condition of used maintained throughout. Okay, so that is nothing but the repeatability. Okay, now what is the difference between accuracy and precision? That accuracy and precision has been illustrated in the following figure that we have understood on the following previous slide. The arrangement may be thought to correspond to the game of dart, where one is asked to strike a target represented by the center circle, which represent the true values. Okay, that central circle or concentric central circle is representing the true value, and the result achieved by the striker is indicated by the marks, cross marks. Okay, so in first diagram, the archer has marked all the arrows in the center or bullseye. That's why the accuracy is high, and whatever the number of arrows he has marked, that marked arrow on the target board is having no much more distance between each and every targeted arrow. Okay, so that's why accuracy and precision both parameters are higher. Okay, but in second diagram, what is happening, that archer has completely missed the bull's eye, and all the arrows targeted by him is at a particular distance, and all the arrows are nearer to the each and every arrow. Okay, or closer to the each and every arrow. That's why in that case the precision is high but accuracy is low. Okay, and in third case we can observe that each and every arrow is having much more distance between each other. That's why we can say that the accuracy, that's why we can say that in the case of third diagram, the precision is also low and accuracy is too much low. Okay, so in first figure we can say that the archer has marked all his arrow in the bullseye. That's why the accuracy as well as precision is high. Okay, but in second diagram we can see that the archer has completely missed all his arrow to target the bullseye, but the number of arrows, or what we can say, that all the arrows are targeted at the same point or closer to the same point. That's why the accuracy may be low but precision is high. Okay, and in third diagram we can say that no any or single arrow is targeted in the bull's eye. That's why accuracy is very much low. And what about precision? The precision is also low because the there is a lot much or very much more distance between each and every arrow targeted on the dash, what we can targeted on the target board. Okay, that's why the precision is also low. Okay, and I think all of you have got what I have explained here. Then next we will means whatever the different static characteristics we have studied, that is nothing but the range and span, resolution, then threshold, then drift. Next we have studied the what we can say that accuracy and precision. These are the sensitivity. These are the various static characteristics. Now uh, to, now we will have to study the dynamic characteristics. Now first we will have to study what is dynamic characteristics. When an instrument is required to measure a time varying process variables, okay, on one has to be concerned with the dynamic characteristics. These characteristics quantify the dynamic relation between the input and output. Okay, means what? When an instrument is required to measure a time varying process variable. Okay, for that, for what? The dynamic characteristics, and these dynamic quantities are dynamic reaction between input and output. Okay, the main characteristics, dynamic characteristics, may be summarized as follows. First will be the speed of response, then measuring lag, fidelity, dynamic error, overshoot, dead time and dead zone. Okay, so one by one we will study all the dynamic characteristics. The first dynamic characteristics is a speed of response. Now the speed of response or responsiveness, it is also known as responsiveness. Now the speed of response or responsiveness is nothing but how rapidly with which an instrument responds to a change in the value of the quantity being measured. Okay, means what? जी काही क्वांटिटी आपण मेजर करत आहे ती क्वांटिटी जेव्हा एखादं इन्स्ट्रुमेंट सेन्स करेल, आफ्टर सेन्सिंग हाऊ रॅपिडली or how quickly the instrument will give the response, that is nothing but the speed of response. Okay, means after giving the input in terms of unknown quantity, that unknown quantity is sensed by the sensor installed in the measuring instrument. After sensing that unknown quantity, that will be sent to the instrument, and after various manipulations, mathematical, algebraic, okay, the instrument will how quickly response to the instrument or response to that input, that is nothing but the speed of response. Okay, understood? Simple terminologies are there. Then next one is the measuring lag. The name itself suggests that there will be certain lag in giving the output after getting the input. Okay, so it refer to retardation or delay. Okay, it is nothing but the retardation or delay in the response of an instrument to a change in the input signal. Okay, means when there will be change in the input signal, so whatever the retardation or delay in the uh, in giving the output by the instrument, that is nothing but the measuring lag. Measuring lag nothing but how uh, the delay, or how much delay or how much retardation in giving the response to the given input signal, or in the given change in the input signals, that is nothing but the measuring lag. And that measuring lag is occur because of the condition of the instrument, that is capacitance, inertia of the moving parts, then resistance. Because of that, the measuring lag will occur in the instrument. Okay, then next, fidelity. Fidelity means what? It refers to the ability of the system to reproduce the output in the same form as the input. Okay, fidelity means what? How, or the instrument is referred to the ability of the system to reproduce the output in the same way as that of the input. म्हणजे ज्या प्रमाणात आपण इनपुट दिला त्याच प्रमाणात आउटपुट देण्याची जी काही रिपीटेबिलिटी आहे किंवा रिप्रोड्यूस करण्याची जी काही ॲबिलिटी आहे इन्स्ट्रुमेंटची, दॅट इज नथिंग बट द फिडिलिटी. ओके, इफ द इनपुट इज साइन वेव्ह फॉर 100% फिडिलिटी. ओके, जर इनपुट काय असेल म्हणते साइन वेव्ह फॉर दी 100% फिडिलिटी, देन आउटपुट शुड बी अ साइन वेव्ह. त्या केसमध्ये आउटपुट सुद्धा साइन वेव्हच येईल. ओके, then next is the dynamic or measuring error. Dynamic or measuring error, if or it is the difference between the true value of the quantity changing with time. It is the difference between true value of the quantity. It is the difference between true value of the quantity changing with time and the value indicated by the measurement system. Okay, and that is if no static error is assumed. Okay, when there will be no static error is assumed, in that case whatever the difference between true value of the quantity to be measured and the value indicated by the measurement system, that is nothing but the dynamic error. Okay, so the dynamic error means what? It is the difference between the true value of the quantity changing with time and the value indicated by the measuring instrument. Okay, by assuming no static error. Okay, so that is nothing but the dynamic error. Then next parameter or next dynamic characteristics we will have to study, that is overshoot. Overshoot means what? When we measure the any unknown quantity by using instrument having analogous system or deflecting pointer. In that case, how the overshoot is explained? Because of the mass and inertia of the moving part of the measuring instrument. In every measuring instrument we know that there are number of moving parts. Okay, number of moving parts, that's why because of the number of moving parts, the mass and inertia of the moving part, there will be uh, the error. That error is nothing but the pointer of the instrument does not immediately come to rest in the final deflected position. Okay, means once we have given the input to the instrument, that case you have observed in case of the uh, what we can say that in case of the driving the bike. Okay, once you have raised the speed of the vehicle or speed of the bike, the pointer will goes beyond the certain limit. Okay, and it will take certain time to come to the original position or original point. Okay, so uh, it will move beyond the steady state or steady position. Okay, so that in the case of measuring instrument, we can say that because of the mass and inertia of the moving parts, the pointer of the instrument does not immediately come to rest in the final deflected position, because in final deflected position the pointer will pass the steady position. Okay, that's why it will require some time to to come to rest, or what we can say that come to rest or come to below the steady state position. Okay, the pointer goes beyond the steady state, that is its overshoot. In diagram we can say that, or we can see that here, this is the overshoot. Means this horizontal line is the final steady state position, and this graph is just passing the steady state line. So this bell shaped structure is nothing but the overshoot. Means what, the pointer will show the deflection much more higher than the steady state. That's why we are getting the positive loop. Okay, that positive loop will indicating the overshoot. Okay, and the overshoot is defined as the maximum amount by which pointer moves beyond the steady state. Okay, so maximum uh, amount by which pointer moves beyond the steady state. Okay, what we can say that overshoot is defined as the maximum amount by which the pointer moves beyond the steady state. Okay, that is nothing but the overshoot. Okay, so this is nothing but the different dynamic characteristics we have studied. First dynamic characteristics we have studied, that is speed of response, it also known as responsiveness. Then measuring lag, fidelity, dynamic error, and next one we have studied overshoot. Okay, so these are the different dynamic characteristics that we have covered in the today's lecture. Okay, before that we have studied the different precision and repeatability. Then we have studied the threshold and resolution. Before that we have studied one static characteristics, that is sensitivity and deflection factor. Before that we have studied the drift, what is drift, what are the different types of drift, and what are the causes of occurrence of the drift in the instrument. Before that we have studied hysteresis, what is hysteresis, how we can practically understood how the hysteresis will occur in case of the measuring instrument. Before that we have studied what is calibration, that calibration we have explained with the help of measuring spring balance. In that case we have studied accuracy, error, correlation, and the first static characteristics we have studied, that is range and span. Okay, so these are the different static characteristics such as range and span, accuracy, error, correlation, calibration, then hysteresis, drift, then we have studied sensitivity, deflection factor, threshold, and resolution. These are all the static characteristics we have studied. In addition to the precision and repeatability, these all are the static characteristics. And in dynamic characteristics, the speed of response, measuring lag, then fidelity, dynamic error, and overshoot. These are the different dynamic characteristics. And dynamic characteristics means what? When an instrument is required to measure time varying process variables. टाइम व्हॅरिंग प्रोसेस व्हेरिएबल स्टडी करायसाठी जे काही इन्स्ट्रुमेंट असतात, दॅट शोज दी डायनॅमिक कॅरेक्टरिस्टिक्स, अँड दॅट डायनॅमिक कॅरेक्टरिस्टिक्स वी हॅव स्टडीड इन दिस lecture. So in the next lecture we will study what is dead time and dead zone. Then we will study what is zero, first and second order system with the help of examples. So then we will have to study the transient response, transient steady state response, and then error, classification of error, cross error, systematic error, random error. These types we will have to cover in the next lecture. So today we will stop over here. Thank you.